Hey everybody, Dr. A here, and in this video we're going to be exploring an example of using the dot product. But before we get started, please hit like and subscribe and also be on the lookout for other content like this. Let's get started now. In this example, we're being asked to compute the angle theta between the two vectors. So let's go ahead and draw our figure, and all of this is still given information, by the way. So we're going to have a two-dimensional problem here. We're going to have a set of x, y coordinate axes, just like this. And we're going to have one vector right here. And this is going to be f1. And if we look at vector f1, this is going to have units of 7. And this is going to have units of 5. And both of these axes carry units of kilonewtons, by the way. These are still force vectors. And then over here, we're going to have vector f sub 2. And this is going to have a magnitude of, or a location of 6, but in the negative x direction. And then this is going to have a height of 2 right here. So this is our given information. And the angle that we're being asked to find is this angle theta right in between them. Okay, so right here is angle theta. So under solution, the first thing I just want to point out is vector f1 has the components of what? Well, it's got components of 7 kilonewtons, comma, 5 kilonewtons. And then vector f2 has components of negative 6 kilonewtons and positive 2 kilonewtons, okay? And so remember to find angle theta. We're going to say theta equals, and we saw in the previous video, we have arc cosine of, in this case, it'll be little f1x times little f2x plus little f1y times little f2y divided by the magnitude of f1 times the magnitude of f2, okay? And we take the arc cosine of all of that, all right? So again, we're using the form where we multiply the corresponding components together, and then we add all of those together as well, all right? So, let's go ahead and get the magnitudes, right? What's the magnitude f1 going to be equal to? Well, that's simply 49 kilonewtons squared plus 25 kilonewtons squared. So let's see what we get with that. And you need to take the square root of that, of course. So I get a magnitude of about 8.602 kilonewtons. And then my magnitude of F2 is going to be square root of 36 kilonewtons squared plus 4 kilonewtons squared. And we would end up getting the square root of 40 here. So that would be a magnitude of 6.325 kilonewtons, all right? And so piecing this together, we're going to have theta equals arc cosine of 7 kilonewtons times negative 6 kilonewtons plus 5 kilonewtons times 2 kilonewtons, all divided by 8.602 kilonewtons times 6.325 kilonewtons. And we take the arc cosine of all of that. So let's punch this carefully into our calculators. I'm in degree mode right now, by the way. So I got 7 times negative 6, and I add that to 5 times 2. And then we divide all of that by 8.602 times 6.325. And then we're going to take the arc cosine of that value, and I end up getting a angle of 126 0.03 degrees. And that is my answer. And if you look at the original figure from the problem statement, that seems reasonable, right? I mean, that seems based on how we drew this, even though it wasn't exactly to scale, but that does look like a pretty obtuse angle, and it's 126 degrees. Now, one other thing I do want to mention is this type of formulation, put a little note here, this is valid for angle values between 0 and 180 degrees. I can't remember if I mentioned that in the previous video or not. I guess I could go back and watch the previous video and see if I mentioned it or not, but the textbook definitely discusses that. So if you don't have an angle between 0 and 180 degrees, it may give you a false computation, or you just need to kind of adjust your quadrants to fit it into a 0 to 180 domain.